Hi, I'm Julius Giorgio. I head the Holistic Electronics Research Lab in the Department of Electrical and Computer Engineering. In this laboratory, we design chips and electronic systems, mainly with applications to the areas of biomedical electronics or bio-inspired electronics. The lab is fully equipped with all the software we need to design the chips, but also to test the chips that we have manufactured at free play foundries. The lab usually has between 8 and 12 researchers working here, depending on the grants that come into the lab. We'll go for a quick tour of the lab and you can see some of the facilities that we have here. It's extensively equipped in order to be able to test, for example, reference circuits. This here machine is a temperature chamber. It goes from minus 160 degrees all the way to 220 degrees. Here we have an X-ray inspection system. We have mixed signal oscilloscopes, logic analyzers, vector network analyzers. For some of the work that we do, we require optical tables for fluorescence imaging. We also have a probe station for probing the chips that we manufacture, but also a laser cutting system that can operate on the chips and cut some tracks off. We have a wire bonder and more equipment. So this is our thermal chamber. We use it for testing electronics across extreme temperatures. For example, we can test something and see if it works at minus 60 degrees or even at 120 degrees centigrade. This is an X-ray inspection system. Here we can see an image of some chips on a PCB where the solder bumps are at the bottom, and we're checking to see that the contacts are where they should be. So here we have some of our key instruments. This is a top-of-the-range logic analyzer, and this is a mixed signal oscilloscope that can measure both analog signals and digital signals at the same time. Here we have a 3D printer where we can prototype some of our designs and package the electronics as they would be in a product. Here we have our soldering station where both undergrads and postgraduate students will come to work on their projects and connect the components onto their PCBs. This is our optics room where we conduct experiments with fluorescent imaging with biological samples and design our electronics to work with these kind of materials. So in one of our projects we needed a very specialized packaging process for the metamaterials, and as such we commissioned a service outside the regular foundry that would put solder bumps onto the chips at a wafer level for wafer level chip scale packaging. And this is a sample of the work that they did. Again, this is from Taiwan, but not from TSMC. Here
we are using software for designing the chips. We are using Cadence software and Synopsys software. We first designed the circuit as we show in the picture in the design here, and from that circuit we are deriving the layout, which as you can see there are 180 nanometers of lines. Each color represents a different line, and then once we are ready we manufacture the chip, and we have the manufactured chip here. This is one of our manufactured chips used for adaptive metal surfaces. It's a 2mm by 2mm chip.
Today you caught me in the middle of my work. So basically today we're troubleshooting a metal surface which we equip with our custom ICs. Hopefully you have some footage of this later on. And I'm programming our metal surface through our custom PCB here, basically an Arduino and a translator board, which I am programming through a script on my laptop. Well, this is basically my day today. Hope you're having a better one, and hopefully you will have some time to see it up close with the camera.